Alright, so this is problem 17 from 10.2, and it's asking to find horizontal and vertical tangents for this parametric function. Now, we're still using the formula dy dx is equal to dy dt over dx dt. And now basically the only thing is when we're finding horizontal tangents, we're trying to find when this thing is 0, right? So it's 0 when dy dt, the numerator, is equal to 0. So that's a horizontal tangent. And a vertical tangent, i.e. it's undefined, is basically when the denominator, dx dt, is equal to 0. So that's vertical. Okay, so let's actually take those derivatives and try to find at what t values this happens. So dy dt, and this is looking for, again, horizontal, because we're just trying to get the derivative to be 0. And so dy dt is 2t, and all I did was differentiate that. So that occurs just at 0, right? This is equal to 0 when t equals 0. Okay, so that's our horizontal asymptote. Horizontal tangent. And then our dx dt, so our vertical tangent. Let's actually take that derivative now. 3t squared minus 3. And let's set it equal to 0. From there, we can factor out a 3. So it's equal to 0 when t is equal to plus or minus 1. So 0 product rule, we can set that equal to 0. All right, and from there we have 3 different t values at which we have tangents. Now we can plug them in to x and y to find the actual xy coordinate that the tangent occurs at. So let's just start off with the horizontal one, just because we just have one of them, right? And that was when t is equal to 0. Okay, so x of 0 is 0 cubed minus 3 times 0 is just 0. And then y of 0 is equal to 0 minus 3 equals negative 3. So we have a horizontal tangent at 0, negative 3. And then, the vertical one, so this was at t equals negative 1 and t equals 1, so we have to plug in both of those. So let's find the coordinate pair for negative 1 first. So x of negative 1, just going back to our function, so it's negative 1 cubed minus 3 times negative 1. I believe, yes. So that just stays negative 1. So that becomes 2. So our x value is 2 at t equals negative 1. And let's see what our y value is. Okay, it's negative 1 squared plus minus 3. So that is equal to negative 2. So this coordinate is 2, negative 2. So that's one of the vertical tangents. And now let's do the pair for just 1. So just plugging it into the function again, x function, we get negative 2. And then let's see what we get for the y. We get negative 2. Okay, so it looks like, and that makes sense because it's an even function for the y, so that's why we get the same output here. So we have 3 different tangents. One horizontal one that occurs at 0, negative 3, and 2 vertical ones. One that occurs at 2, negative 2, and the other one that occurs at negative 2, negative 2. And that summarizes that problem.